Okay, so now we're going to look at the situation like where you got certain musical instruments, like the flute. That was I was thinking of. The flute has got open on both sides. So you get sounds forming from that. You got your organs and that sort of thing, your pipe organs. I'm not quite sure if they're open on both sides. We're going to look at the both. We're going to look at the one where you've got open ended and closed at one ended. So we have those different situations. Now, one thing that you always have is that nodes exist always at closed ends. You can only form the particles will always form a node at a closed end, and you can only have an anti-node at an open end. So we have those. That's what happens. Again, I'll show you that video. It works. It's quite nice. It will show the example of that. So we're going to firstly looking at this is where it is open at both ends. So you've got to have your antinode on both sides, and this is the simplest possible situation that you're going to have, where you have here your first harmonic. It's how many this if this is L. You can see here. I hope you can see that this is half a wavelength. Are you okay with this? Because if I extend this down here, it would come down to there, and this would that would be like that. Well, I'd actually only go up to there really, and I'd have to go up to there, so I'd have another half there. So this is half. So we as before, we get our frequency is equal to V over 2L. I don't need to go through that all again. That's straightforward. So we can build up for our next one. When we go to our next one, now we get our L is equal to lambda. Like with the fixed on both ends, the antinode on both ends gives the same result. So we get F is equal to V over L. And then when I go on to this, I go again. I get again 3 over 2, or the lambda is 2 over 3, so I get the same thing. So you actually get exactly the same result with your fixed ends as you do with your open ends. You get the same harmonic series that is formed. So it's pretty straightforward. We don't have to worry about it too much. We get the same sort of situation. So we get the harmonics are in the same series as the string series, and it starts with the fundamental frequency F, and we get the same result. But with this situation over here, with the fundamental frequency, where we are a fixed end, where we get our fixed end and we get our open end, so we get our node here and our anti-node here. The first fundamental frequency that we can get is actually a quarter of a wavelength. Okay, where you get this is vibrating like this up and down. And so our lambda, our first harmonic, we have lambda is equal to 4 over L. So we get our fundamental frequency is 4 over 3, V over 4L is our fundamental frequency. Are you okay with that? Okay, so what happens with this one though is that when we go to our next one, because you've got your antinode is always being formed on one side and you've got your node on the other side, you can't get the half wavelength in, because a half wavelength requires an antinode on both sides, or a node on both sides. It needs one of those two to get half. So the next one you've got to go to is your 3/4. All right, like this, or lambda is equal to 4 over 3. So you get this situation over here where you get your frequency is 3V over 4L. This is closed over here. This is your closed over here, your closed pipe, and this is your open over here. So that's something like the clarinet. Apparently, it's because the clarinet, the one side is closed. Yeah. Okay. So going on to the next one. If we go on to the next one here, um, we're over here. Sorry, this should be a lambda here. Not sure what that symbol is. Uh, we've got the next one is actually going to be 5/4. All right, so we're getting our lambda is equal to that, and so we get f is the frequency is 5/4L. So basically, what we have in the end result with this is we get this type of situation is different. You don't get a second harmonic and you don't get a fourth harmonic, but you just get the odd harmonics that actually come out. You get your fundamental frequency and your third and your fifth and your seventh and your so forth frequencies coming out. Now, you'll do a few. I'll give you some examples to work with this, and it becomes clearer when you're actually working with problems. But it's pretty straightforward when you actually. The maths behind it is